Hello students, welcome to my class. Today I will take class 9 chapter 10. Chapter name is circle. In this chapter we will deal with circles and its various parts. So before starting the chapter, let us discuss about circles. So circle is what is circle? The circle is a collection of all the points in a plane which are at a fixed distance from another fixed point in the plane is called a circle, and the fixed point is called the center of the circle. Circle. This is a circle. So the collection of all the points in a plane which are at a fixed distance from another fixed point in the plane is called a circle, and the fixed point is called the center of the circle. Here we will give the name of the center as O. This line is nothing but a collection of points and which are at a fixed distance from the fixed point. You see this line, and this line, and this line, all are the fixed distance from the points. Okay, so this line is called, curved line is called circle, and the point which is at a fixed distance is called center of the circle. In a circle, as we will discuss about the parts of the circle, in a circle, if we join a line segment from the center to the circle, is called radius of the circle. So radius is the line segment joining the midpoint of the line segment joining the center of the circle is called radius of the circle. Radius is a line segment joined from the center to any point of the circle. Center to any point of the circle. So this is radius. Okay. Then chord of a circle. This is a circle, a line segment joining any 2 points of the circle is called chord of the circle. Here AB is the chord of the circle. Here OA is the radius of the circle. AB is the chord of the circle. Now diameter. When a chord passes through the center of the circle is called diameter of the circle. You see, earlier I said a chord is a line segment joining 2 points of the circle. Joining any 2 points of the circle is called chord, and when a chord passes through the center of the circle is called diameter of the circle, and diameter is the twice of radius. Radius was a line segment joining from center of the circle, and chord was any point of the circle, and when a chord passes through the center of the circle is called diameter of the circle. Okay. Now arc. You see, this is a circle, and this line is called perimeter or circumference of the circle. Okay, and the portion of the circle, a portion of the circumference of the circle is called arc of the circle. If it is a portion of the circumference, the total outer boundary is called the circumference of the circle, and a portion of the circumference of the circle is called arc of the circle. Here AB is the arc. Okay. Now segment. Segment. You see, when we draw a chord on the circle, it bisects. It divides the circle into two parts. Bisect, not bisected. Divides the circle into two parts. Each part is called segment of the circle. When a chord divides the circle into two parts, each part is called segment of the circle, and the larger part is called major segment. And the smaller part is called minor segment. Again I am repeating, a chord divides a circle into two parts. A chord divides a circle into two parts. Each part is called segment of the circle. The larger part is called major segment, and the smaller part is called minor segment. Next, sector. If it is circle, then these two are the radii. Okay. OA and OB are the radii, plural form of the radius, radii of the circle, and the area bounded by two radii and the corresponding arc is called sector of the circle. You see this part. These two OA and OB are the radii. OA and OB are the radii, and this arc AB, the area bounded by the two radii and the corresponding arc is called sector of the circle. Okay. The smaller part is called minor sector, and the larger part is called major sector. Quadrant of the circle. Next, quadrant. 1/4 part of the circle is called quadrant of the circle. 1/4 part. That is, if we draw two perpendicular diameter in a circle, then the circle will divide into 4 equal parts. Each part is called quadrant of the circle. Okay. Each part is called quadrant of the circle. So, last but not the least is semicircle. Semicircle. A diameter divides a circle into 2 equal parts. Each part is called a semicircle. When we draw a diameter, that is a chord passes through the center, it divides a circle into 2 equal parts. Each part is called semicircle. Okay. So, these are the parts of the circle. Let us write the definition in full. So, circle, write down with me. The collection of all the points in a plane which are at a fixed distance from another fixed point is called a circle. And the fixed point is called center of the circle. Okay, this is the definition of circle. Here O is the center. Now radius. What is radius? The line segment joining the center to the circle, to any point of the circle, is called radius of the circle. So Y is the radius. Now chord of the circle. The line segment joining any 2 points of a circle is called chord of the circle. So here I am drawing the chord of the circle. AB is the chord of the circle. Now from here remaining definitions, again I am repeating. Diameter. When a chord passes through the center of the circle, then it is called diameter of the circle. Okay. When a chord passes through the center of the circle, then it is called diameter of the circle. Arc. The portion of the circumference of the circle is called arc of the circle. Arc. A portion of the circumference of a circle is called arc of a circle. Here this is a circle and A and B is the chord of the arc of the circle. Now segment. Write down these definitions in your notebook. Segment of a circle. A chord divides the circle into two parts. Each part is called segment of a circle. Now we will draw a circle and a chord AB. So these two parts, here the larger part is called major segment and the smaller part is called minor segment. Okay, so this is major, and this is minor. Now next is sector. Sector of circles. The area bounded by two radii and the corresponding arc. Is called sector of the circle. Okay, like this. So these are the two radii as I showed earlier, OA and OB, and this is the arc. So this portion is called sector. Okay, then that portion is called sector, but it is termed as major sector, and the smaller is called minor sector. This about your definitions. Now there is an exercise 10.1. Here some statements are there and some blanks are there. From the discussed topic we have to answer about the parts of the circle. Now center of the circle lies dash of the circle. Option is given exterior, interior. So center of the circle lies interior of the circle. Your answer is interior. A point whose distance from the center of a circle is greater than its radius lies dash of the circle. A point whose distance from the center of a circle is greater than its radius. You see, there is a point whose distance is greater than the radius. Radius is up to here and point is up, suppose here. So sorry, here option is interior or exterior. Suppose this is a circle, its radius is this and the point is here, so it will be exterior of the circle. The longest chord of a circle is called dash of the circle. You see, earlier I discussed about the chord. So this is a line segment joining two points of the circle. All these line segments I am joining 2 points, and among them one is the longest, and which is this, the line which passes through the center of the circle is called diameter, and this is the longest chord of the circle. If we draw more than 2 or 3 chord, the chord which will pass through the center will be the longest. So here your question, the longest chord of the circle is dash of the circle is diameter of the circle. An arc, next question, an arc is a dash when its ends are the end of diameter. An arc is a dash. I said the portion of the circumference is called arc of the circle, and here your question is, an arc is a dash when its ends are the end of diameter. If it is center of the circle and if we draw a line segment through the center and if you remove this upper portion, okay, and diameter, the name of the diameter is AB. A is the one end point and B is another end point of the diameter, and this curve AB is the arc of circle, and when the end point of diameter is the end point of the arc, then the arc is called semicircle. Okay. Next question. Segment of a circle is the region between an arc and dash of the circle. Just I discussed segment of the circle is the region between an arc and the chord of the circle. This is a chord and this is an arc. This is the segment. Okay, so your answer is chord. Segment of a circle is the region between an arc and chord of a circle. Next question is, a circle divides a plane on which it is lie in dash parts. A circle divides a plane on which it is lies in how many parts? Just I am drawing it for better understand. This is a circle. Suppose it is a circle. I drawn this circle in the plane. It divides the plane into how many parts? 3 parts. One is inside the circle. Earlier it was plane. After drawing it, it became 3 parts. One is inside the circle. Another is outside the circle. And the third one is the circle itself. So, a circle divides the plane on which it lies in 3 parts. Next, write true or false. Give reasons of your answer. Line segment joining the center to any points of a circle is a radius of the circle. The line segment joining the center to any points on the circle is radius of the circle, as per definition I said earlier. So it is true. A circle has only finite numbers of equal chords. A circle has only finite numbers of equal chords. A circle has only finite numbers of equal chords. Yes, it is true. Equal chords. Infinite number. I think it is infinite number. A circle has infinite numbers of equal chords. If a circle divides into 3 equal arcs, each is a major arc. If a circle divided into 3 equal arcs, each is a major arc, it is false. A chord of a circle which is twice as long as radius is the diameter of the circle. True. Sector of the circle, sector of the region between the chord and the corresponding arc. Sector is a region between the chord and its corresponding arc. I said sector is a region area bounded by 2 radii and the corresponding arc. Here said chord and this corresponding, so it is wrong, false. A circle is a plane figure, it is true. Okay, so write all this statement in your exercise book and write the true answer. So this is about your exercise 10.1, and here some definitions are there. Now one will try to solve 1 or 2 theorems. You see, theorem 10.1, equal chords of a circle subtend equal angle at the center. This is a theorem, we have to prove it. Page number 195 of this book. Open page number 195. Equal chords of a circle subtend equal angle at the center. This is your theorem, we have to prove that. Equal chords of a circle subtend equal angle at the center. We have to probe it. So to probe it, let us draw a circle, and here we are drawing two chords, equal chords. AB and CD are two equal chords of a circle. So let AB and CD be two equal chords of a circle with center O. So here center required O. We need to prove that these two chords subtend equal angle at the center. So AOB and COD angle AOB and angle COD are two angles subtended at the center. By the chords. Chords AB and CD. To prove that, angle AOB is equal to angle ACOD. We have to prove this. This is a theorem we are proving. So to prove a theorem, we need four parts. What is given, what is to prove, construction if necessary, then proof. What is given we have written already, what is to prove also we have written, construction if required. So in this particular theorem, no need of any extra construction. Now we are turning to the part proof. To prove this theorem, we will use the congruency of triangle. We will use the fundamental of congruency of triangles. So you see, these two chords with these two angles form two triangles. So in triangle AOB, its name is OAB, and triangle OCD. If we compare, then what we are getting? OA is equal to OC, OB is equal to OD, and AB is equal to CD. OA is equal to OC, OB is equal to OD, we got from since radii. Okay, and AB is equal to CD, it is since given, because in question it is given that equal chords. So by we are comparing these two triangles. Between these two triangles, we got side is equal to side, side is equal to side, and this side is equal to this side. That is postulate of side, side, side. Therefore, by SSS congruency, rule, triangle OAB is congruent to triangle OCD. So when we get two triangles are congruent, then generally we get one simplicity or two simplicity. So after proving these two triangles are congruent, we got one simplicity that AOB is equal to COD. When we prove two triangles are congruent, then we can say that other parts of the triangles are equal. Generally, in two triangles, in a triangle there are 6 parts, 3 sides and 3 angles. Here also 3 sides and 3 angles. In this proof, we have used 3 sides. So we can say that other 3 angles are equal. But we need one angle, so we can say that angle AOB is equal to angle COD by CPCT. CPCT means corresponding part of congruent triangles. So here it was to prove and it is proved, hence proved. So next theorem is theorem 10.2. If the angles subtended by the chord of a circle at the center are equal, then the chords are equal. Now we are proving theorem 10.2. As it is just reverse of this one, converse of this theorem. Earlier in theorem 10.1 it was the chords were equal, and we proved that the angles subtended by these two chords are equal. Now in theorem 10.2 it is said that if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. We have to prove that. This will be the last theorem for today's class. So again we are drawing a circle. And two chords AB and CD on it. Theorem 10.2 prove that if the angle subtended by the chords by the chord of a circle at the center are equal, then the chords are equal. This is your theorem we have to prove. So, starting the solution. Let AB and CD be two chords of a circle with center O. Subtending two equal angles angle AOB and angle COD at the center. This is what is given part. To prove that center forming triangle AOB and triangle COD. We have to prove that AB is equal to CD. So, what is given, what is to prove? Construction not required for this particular theorem, and now we are going to prove. Proof part, fourth part. Sorry. As I said, these two chords subtend to a equal angle at the center, forming two triangles AOB and COD. So, considering these two triangles, angle AOB and triangle COD. So, what we are getting, OA is equal to, if you compare them, OA is equal to OB, since radii, angle AOB is equal to angle COD. From where it is? Since given, it is given in the question that angles subtended at the center are equal, and third part is OB is equal to OD. Sorry, here it is OC. OB is equal to OD, again radii. So, therefore, which postulate? Side and their corresponding angle. Side and their corresponding. That is, this postulate's name is side angle side. Therefore, by side angle side postulate, triangle, name of the triangle I have given AOB. AOB is congruent to triangle COD. As I said, after congruency, the remaining parts of the triangle are, two triangles are equal, So here we will use the sides part. Therefore, we can say that AB is equal to CD by CPCT, or CPCT simply write CPCT. Hence, this was to prove. Hence, we can say that hence chords are equal. Proved. This is about your theorem 10.2. So, in today's class we have discussed about theorem 10.1 and 10.2 along with that parts of the circle. Now exercise 10.2, recall that two circles are congruent if they have the same radii. Prove that equal chords of congruent circles subtend equal angles at the center. So next day we will prove this theorem. Now time is not permitting for today's class, so I am bound to conclude. So next day we will start from exercise 10.2, that is two theorems, and I will continue to 10.3. So for today's up to this. Thank you.